The extended Euclidean algorithm is a way of answering questions like this, where x and y have to be integers. One's going to be positive, the other one's going to be negative. And it's not really obvious what the answer to this question is, so there's a method for doing a question like this, and it goes like this. You take the bigger number, in this case the 120, and you ask how many times the smaller number, 23, go into 120. The answer is 5 times, but there's a remainder 5, so the work would look like that. Then we do this again, but this time we use the 23 on the left, and we use the remainder, which was 5 over here, and we say how many times does the remainder go into 23. The answer was 4, remainder 3. Here's a little bit of work for that. And again, this time we keep using this number, and we see how many times this one goes into it. So it's 1 times remainder 2, and then 3 equals 1 times 2, remainder 1. And we stop at that point. We stop when this number is equal to that one. These 4 equations are going to be used to create an equation that looks a lot like this original one. I'm going to take the 4 equations and I'm going to rewrite them. This equation down here, I'm going to subtract the 1 times 2 from both sides, and I get 3 minus 1 times 2 equals 1. If I do the same thing with this second equation, it turns into 5 minus 1 times 3 equals 2, and the second equation here becomes 23 minus 4 times 5 equals 3, and the top one becomes 120 minus 5 times 23 equals 5. These 4 equations came from these original 4 equations. Now comes the big process. We take this bottom equation here, and we replace this 2, noticing there's a 2 here also, with this entire expression. So it turns into 3 minus 1, parentheses 5 minus 1 times 3 equals 1. Then we distribute this negative 1 through. Negative 1 times 5 is negative 5, but we're going to write it as negative 1 times 5. And I'm going to write this 3 as 1 times 3. And when I distribute this one through, it becomes plus 1 times 3 equals 1. Then I'm going to combine the 3's. There are 2 of them, so I get 2 times 3 minus 1 times 5 equals 1, which is true. You can test it. 6 minus 5 is 1. Now I'm going to take this 3 here and replace it. Since there's a 3 over here on the right, I'm going to replace it with this expression. It's going to become 2 times 23 minus 4 times 5 minus 1 times 5 equals 1. Distribute the 2 through, but leave the 23's and the 5's almost like they're variables, so it just stays as 2 times 23 minus 8 times 5 minus 1 times 5 equals 1. See, there's minus 8, there's a bunch of 5's that can get combined, so 2 times 23 minus 9 times 5 equals 1. And you can just check that. 46 minus 45 is 1. Finally, I'm going to replace this 5. According to this expression, the 5 can be replaced with this thing, 120 minus 5 times 23. So I'm replacing the 5 with 120 minus 5 times 23. 2 times 23. Distribute the negative 9 through. It becomes minus 9 times 120. We don't actually multiply, we just leave them like that. Plus 45 times 23 equals 1. There's 2 23's, there's 45 23's, so I get negative 9 times 120 plus 47 times 23 equals 1. And the question was 120x plus 23y equals 1. So the negative 9 is the x, and the 47 is the y, which was the answer to that question. This is called the back substitution method. The answer to this question was negative 9 and 47. You could test that by plugging those numbers in and see it does equal 1.